As we talk about these filter and delay devices, it's important to understand the basic fundamental building block. In fact, they're all kind of crafted around this one kind of module with just a few parameters, but it's really important that we understand it because it all builds from this. It's kind of the delay building block, and it includes delay time. That's the amount of time from the input to the output. It includes a dry-wet, which is a mixture of the wet signal, and wet's kind of a funny term, but the wet is the delayed signal, and the dry is the undelayed signal, and the feedback, which is how much the wet signal is routed back to itself. In this video, we're just going to look at the basic delay concept, get a feel for those controls, and then we'll move into the larger plugins and larger effects that are built from this basic building block.
In this demonstration, input will be on the left, output will be on the right. Input will always be in green, output will be in red. There's a diagram in the bottom which shows input and output clearly. The signal enters from the left and is split into two halves. The top half is known as the wet part, and the bottom half is known as the dry. Wet in any delay context just means the delayed signal, and the dry is the undelayed signal. On the wet side of this diagram, we see the delay unit, and the delay unit really just holds on to sound and then releases it a little bit later. We have delay time, which controls how much the delay unit waits before it releases that sound. The dry-wet control at the end allows us to blend between the dry undelayed signal and the wet delayed signal, and the feedback control routes the delayed signal back to its input so that the delays can repeat over time. Throughout this video, I'll be using a simple sound. Let's hear it. In the display, we're seeing the green and red trace are exactly the same. The input is the same as the output, which will always be the case when your dry-wet balance is set all the way to the dry side, which means that input is output. We're only hearing the dry side of this path. If we turn that dry-wet balance all the way to the wet side, we'll hear only the wet. I'm also increasing delay time a bit. Let's hear it. This time, you only heard the second delayed signal. The green is the input, but since the dry-wet balance is all the way to the wet side, we're only hearing the delay at the output and none of the dry path. We're only hearing the wet path. We can mix both the dry and wet together in any proportion. If I set it in the middle, we'll hear both the dry and wet side at the output of the delay block. The output includes the original dry, but it also includes the delayed signal. Typically, we put the dry-wet toward the left so that the delayed signal is quieter than the input dry. That helps the listener to differentiate which is the original signal and which is the delay. But we can also do some unusual things. If I was to turn the dry-wet balance very high, we might get a situation where the wet delayed signal is actually louder than the input dry signal. We also have a feedback control, which routes some of the output of the delay block back to the input of the delay block. The feedback control is only a gain stage. It's increasing the level of the signal going back to the input of the delay. If you put feedback too high, the sound will continue on forever. And if you put it down low, the delays will fade away quickly. Let's see the effect of feedback. Now, we get a series of repeats. If I lower the delay time down, those repeats will be closer together. If I increase feedback, those series of delays will continue on for a very long time. That really is the basic functionality of a delay device. This knowledge will translate to all of the other delay devices that are built from this block. Choruses, phasers, flangers, short delays, long delays, reverbs, and even our filter devices are built from this simple block.